When I solve by square root, it's in a situation like this where I have something is squared. Now look, like here something is squared. Remember my goal is to get x by itself always. Here I can't get x by itself by square rooting because there's another x over here, right? So that's like a totally different situation. But here, the only thing that's happening to x is it's being squared, and I want to get rid of the squared to get x by itself. So I just do the inverse, right? Squared and square root are inverses, and so when I see squared, I'm like, oh, I can just square root to get rid of the squared. Now, if I square it on the left side of the equation, I have to square it on the right side of the equation. And here's the thing. When I square root 36, there's two answers. Because the question is, when I square root 36, what number times itself equals 36? And the answer is, could be 6, could be negative 6. So we write it like this. We say, oh, it could be plus or minus 6. And then we write, there's two answers, right? There's negative 6 and positive 6. And our work looks like this. Okay, and you can kind of plug back in and see, oh, is negative 6 squared 36? Yep, negative 6 times negative 6 is 36. Is 6 times 6 36? Yep, it is, right? So that works. Okay, now here, the only difference is there's still something being squared, right? Now the thing that's being squared is this set of parentheses. So I still want to get rid of the squared. And notice that on this side of the equation, on the left side, there's something squared, there's nothing else. So my next step is to square root, and I'm going to bring down now the square root and the squared, they get rid of each other. So this is x plus 5. Okay, notice I'm not squaring the 5, right? The square root and the squared, they cancel. That's all I've done is cancel the squared. So I'm bringing down what's inside the parentheses. And then the square root of 81 is plus or minus 9. So this is where I end up with two equations, because x plus 5 could equal negative 9, or x plus 5 could equal positive 9. So when I solve to get x by itself, I'm subtracting 5. I get x equals negative 14, or here if I subtract 5, I end up with x equals 4. Okay, so x equals either negative 14 or 4. Okay, and notice once again, I can plug in, look, negative 14 plus 5, that'd be negative 9 squared. Yep, negative 9 times negative 9, that's 81. 4 plus 5, that'd be positive 9, 9 squared. Does that equal 81? Yes, it does. Now, over here, something different happens. See, here's the part that's squared. It's not by itself, though. So I can't square root because there's other stuff here. I can't just square root right in the middle of the equation. I have to get that part by itself. So I'm going to get rid of the 4 and the 8. And look, the first few steps I'm going to do are just as if this was the equation, right? And I'm just trying to get this part that's squared by itself, the same as I was trying to get x by itself. So first I'm going to subtract 8. 108 minus 8 is 100. Okay, now careful, because a really common mistake here is just to square root it and say, oh, it's plus or minus 10. Nope, there's a 4 here. Okay, now that 4, you can't just distribute it, because what this says, this actually says this, right? That says that. We're not trying to distribute into that. That's too much work. Nope, we're going to get rid of this 4. This 4 is being multiplied. I'm going to divide it. And now, I still have this part is still squared. This equals 25. And now this problem is very much like this one was, right? Where I have something squared, I'm going to square root it. I get x minus 3 equals the square root of 25 is plus or minus 5. So here's where I break it into two separate equations, where x minus 3 could equal negative 5, or x minus 3 could equal positive 5. And then I add 3 to both sides to get x by itself. This is negative 2, or 8. So x could equal negative 2 or 8.